For 7-4, we are going to talk about nth roots. So to start, I would like for you to try these as a warm-up and focus on the square roots here. This is all review, so pause the video for a second, try numbers 1 through 5, and then we will go over it. For numbers 1 and 2, hopefully those were pretty quick for us. We know that the square root of 81 is 9, the square root of 64 is 8. Now, technically, it should be plus or minus if you are actually taking the square root. Because these are just listed as the positive, you only have to put the positive. So the difference is if like I had the x squared equals 64 and I took the square root, that's where you would have plus or minus 8. But here, there's already like an imaginary plus, so you don't have to put that. For number 3, hopefully it was easy for us. This would just be 3x because the square root of 9 is 3. The square root of x squared is x, right? So the same thing applies to number 5, right? Square root of y to the 4th would be y squared, right? Because y squared times y squared gives me y to the 4th. And then we have number 4. So neither one of these are perfect squares. So what we have to do is then split them up. So 12 is 4 times 3. 4 is 2 times 2. So we can rewrite that as 2 root 3. And then we have the square root of x to the 5th. So on these, remember we treat it, we didn't do this in this class specifically, but you should have done it in one of 3. What we do is we take 1 out, and so then you're left with something that, oops, that's supposed to be next. You're left with something that is a perfect square. X to the 4th, just like the y to the 4th, would become x squared. So we have x squared and then 1x left over. Okay, you can also think about it as I have 5 x's. I have a pair for x squared and then 1 left over, so it stays inside. Okay, so my final answer would be 2x squared, square root of 3x for that one. Okay, and we're going to do some more work with that stuff in a minute. So all of the above answers should be positive because the principal square root is the positive root when simplifying. So that's what I was going with at the very top, where we weren't actually taking the square root, so you don't need both. Now let's talk about ways to write powers and roots, all right? The square root actually has a little 2 out in front that you just don't see. We don't see it, we don't write it. It's kind of like x, right? X technically has a 1 out in front and it has a 1 as an exponent, but we never write those. We just write x. Same thing with square roots. Okay, technically there's a little 2 out in front, and that's why we're looking for pairs, because it's what times itself, right? So we're looking at pairs. So again, this is the square root, right? And then 4 to the 3rd equals 64 because it's 4 times 4 times 4 equals 64. So that would be the cubic root. Okay, so the cubic root, you would have a 3 on the outside of 64 is 4. And this should seem kind of familiar because we did it with factoring cubics, right? So 2 to the 5th, that means we're going to type in our calculator 2 and then that little arrow key and then 5, right? So 2 to the 5th, or 2 times itself 5 times, gives me 32. So 1, 2, 3, 4, 5 gives me 32. So it is the 5th root. So anything over cubic, it just becomes the 4th, 5th, 6th, 7th, and so on. So notice how this had a 3, this has a 5. If it's nothing, it's automatically a 2, just like what we referred to up here. Okay, it's just automatic. If it's not a square root, it'll have a number out in front. So the 5th root of 32 would be 2. All right. So that is the main thing from today. Okay. Basically, there's only a couple things that I really wanted you to see from here. Okay, this next part. So basically, the main thing that I want you to get from this is your n is your root. Okay, so that's the number root that you're talking about. And the actual square root, quote unquote, is your radical. Not radical. Technically, the B refers to your radicand. Gosh, I did it again. I can't spell. Radicand. All right, which isn't like super crucial. And the A is your index. Okay, really like your answer when you take the root. Okay, so again, that's just stuff that maybe will pop up, but you do not have to memorize. All right, so I don't want to get too in depth with that. So some of this we can type into our calculator. We talked about this before. If you use your math button, you can see ones that have the third root. So that's nice and easy for the ones that are the third root. Otherwise, there are ones with a box and a root. So you would type your number in and then you would hit the box root and then you could start typing in whatever that is. If we have issues with that on our calculator, let me know and I could show you guys, okay? And every calculator is a little different. Sometimes you can get this one right here and do that first and then arrow over to type in the number root. Kind of just depends, okay? So, number one, we have negative square root of 16. So we always just focus on the square root first, okay, or on the root. In this case, it's a square root, so this is just normal, right? We know the square root of 16, it's 4. And then we have this little negative out in front, which means my answer is negative 4. On the next one, we have the cubic root of 27. So we are going to have to try and break it down. Maybe you remember what the cubic root is, but we have 3 times 9, and 9 is 3 times 3. Now, so far, we have always looked for pairs, but that's because we were always talking about square roots. Now we're talking about a cubic root. So we're not looking for pairs anymore. We're going to look for groups of 3 because it is a cubic root. We need 3s, right? So it just so happens that we broke it down into the number 3 as well. But the cubic root of 27 is 3. And again, you could type that into your calculator and get that. So I know that it's just going to give me 3. Nothing underneath the square root or cubic root because there's nothing left over. The only thing that we have to remember to talk about is this negative. Anytime we have a negative underneath the square root, we need an I as well. On the next one, this is the fourth root of 16. So my answer is not 4 because it's not talking square root here. We're talking fourth root. So we can start breaking it down. It's 2 times 8, 2 times 4, 2 times 2, right? So because it's the fourth root, we're looking for 4 of them. And the fourth root of 16 is actually just 2. Again, I have nothing left over, so I don't need to write anything underneath the root. So we have 2. I don't need an I because it's positive 16, but I do need the plus or minus because it is here in the problem. Example 4, we have the square root of 16. We know the square root of 16, it's 4. And then we have the square root of x to the 8th. Now we talked about this a little bit earlier, but I want to reiterate this a little bit. Whatever number is out in front is basically what we're going to divide this by. So if it's something that is divisible, that is even and it's divisible by it, then all it does is pop that out. So x to the 8 divided by 2 would be x to the 4th. Okay, we would essentially cut it in half. Again, you can think about it as you have 8 and you will look for pairs of 2s. Well, you have 4 sets of x's, right? So that was why it would be x to the 4th. Okay, so our final answer would be for x to the 4th. On our next one, so we have negative and then the square root of x squared minus 6 to the 8th. So let's play off of what we did before, right? Technically, there's a little 2 out in front, right? So we're going to take our degree and we're going to divide by 2. So in reality, we have that negative, and then we have x squared minus 6 to the 4th. Now, technically, we should write this 4 times and FOIL a ton, but we're not going to do that. Super important that we remember that we can't just take this 4 and distribute it. So just leave it how it is. All right, and then we have 243, a to the 23rd, b to the 7th. So let's first start with 243. Okay, I'm going to divide 243 by, let's see, 6? Nope, not divisible by 6. 243 is divisible by 3. 3 and 81. 81 is 9 and 9. 9 is 3 and 3. 3 and 3. So it just so happens that this actually is a perfect fifth. So 3 to the 5th does give me 243. So that means that we can pop a 3 out. Now again, we can have numbers left underneath the root, but right now so far we haven't. So now let's think about the 5th root of a to the 23rd. So what I want to do is rewrite it so that I know I can divide by 5. Well, the closest number that I can divide by 5 without going up, it has to go down, would be a to the 20th. And then we would have a to the 3rd left over, right? Because if you put them together, you're back at a to the 23rd. So I know I can take the 5th root of a to the 20th because we just divide by 5 and you get a to the 4th. Now the other one I'm not going to be able to do, so we just keep it as the 5th root of a to the 3rd. And we're going to do the same process for b to the 7th. So we have the 5th root of b to the 7th. I know that I could take the 5th root of b to the 5th, but I need 2 more b's. So that part's going to stay the same, but this one turns into b because 5 divided by 5 is 1. Final answer is putting it all together. So we have b, a to the 4th, 3 a to the 4th b, and then the 5th root of a to the 3rd b squared. All right, so we're going to keep working with these. What I would encourage you to do is try some of these on your own. And I am going to go kind of fast through some of them. I'll have all of the answers posted so that you can check them later. But we will get to ones that are a little bit different and making sure that we can use our calculator as well. Okay. So number 7. Hey, on this one, again, I need to be able to divide by 4, so that would have to be y to the 4th, and that means that I have 2 left over. So this becomes y, and then we have 4, and then y squared. Okay, now, this is totally fine if you want to advance your math. Technically, I can simplify this one, because this would be y squared over 4, which really turns into y to the 1/2. So in reality, it is the square root of y. Now, I don't anticipate you doing that. Don't feel like you have to. This is a totally acceptable and full points answer. On the next one, the square root of 8, I would simplify it. It's 4 and 2, 2 and 2. So this becomes 2 root 2. But I need an I in it because I have a negative as well. We then have the square root of x to the 7th. So I can take one x out, and now we have x to the 6th, which becomes x to the 3rd when I divide by 2. And then we have y to the 8th. Well, the square root of y to the 8th is a nice number. It's just y to the 4th. So we put it all together for 2i x to the 3rd y to the 4th square root of 2xy. Nope, no y. 2x.